To create stairs, we will start by selecting the first floor plan and zoom into the area where the stairs will be located. Now let's open the Stairs tool. We are now presented with three options that will let us sketch the stairs: run lines, boundary lines, and riser lines. We will start by sketching a run line. In the properties, we will notice some default constraints and dimensions set by Revit. The base level is set for the first floor, and the top level is set for the second floor. The width of the stairs is set for 3 feet, and the desired number of stairs is calculated using a target tread depth of 11 inches and a riser height of 7 inches. To sketch a run line, we will click on a starting location and then move the cursor along the desired path. Revit automatically places risers based on the constraints and dimensions set in the properties. Notice that the risers remaining decreases as the number of risers created increases. Once the full run line has been sketched, we can select the green check mark to create our stairs. Now let's switch to a 3D view to see the stairs that we have just made. If a stair is not in the proper location, it is easy to change their orientation and direction. Let us switch to the first floor plan and select the stairs. By clicking the small blue arrow at the end of the stairs, the direction of the stair is reversed, and it is noted by the long arrow labeled up. We can see this change more clearly in the 3D view. In order to move the stairs into the proper location, let us return to the first floor plan view. We will then start by returning the stairs to their previous direction. Next, it will help us locate the stairs if we underlay the second floor over the first floor in the view properties. As you can now see, the second floor is now faintly visible in the first floor plan view. To relocate the stairs, we will select the stairs and open the Move tool. Click on a point on the stairs to use as a reference, and then select a new location for the reference point. As seen in the 3D view, the stairs are now going the proper direction and are placed in the proper location. Sketching run lines also allows us to make more creative stairs, like L shapes and U shapes. Let us sketch one run line, creating about half of the risers. Next, let's sketch a second run line, perpendicular to the first, creating the rest of the risers. Revit will automatically connect these run lines to create an L-shaped stair. We can see our finished staircase in the 3D view. Although this is not a straight stair, we can still change its direction by selecting the small blue arrow located on the end of the stair. We can also move it into place by opening the Move tool, selecting a reference point, and then choosing an end location. Once again, we can switch to the 3D view to see the finished product. While this technique is useful, it is easy to make a mistake while placing the run lines. Starting from scratch, we will sketch a new stair that contains an error. After placing the first run line, it is important not to place the second one too close. If this is done, a funnel is created in the stairs. In a 3D view, we can more clearly see this funnel and why this error is so important to avoid. Using run lines, we can also create U-shaped stairs. After sketching one run line, let us sketch a second parallel to the first. Once again, Revit will automatically connect these run lines. We can now select the green check mark to finish the stairs and return to the 3D view to see what we have created. Returning to the first floor plan, let us move the stairs into their proper position. Open the Move tool, select a reference point, and select an end location for that reference point. Returning to the 3D view, we can see our finished U-shaped stair. Ramps can be created in much the same way as stairs. Let us return to the first floor plan and open the ramp tool. Once again, we can sketch a ramp by drawing its run line. By default, ramps are set to span between the base level, the first floor, and the top level, the second floor. However, many ramps are used to span shorter distances, so we will set our top level to the first floor and set a top offset of 3 feet. This will create a ramp that is 3 feet high. When drawing our run line, we will notice that the sketch is way too long, which is indicative of a small slope. To change the slope, let us edit the type properties of our ramp. Change the slope from 1/12 to 1/6 and select OK to apply these changes. By increasing the slope, we can now sketch a run line of a more adequate length. Selecting the green check mark will complete our ramp, which can now be seen in our 3D view. As with stairs, ramps can be made into L and U shapes. Open the ramp tool and set the desired properties. Let's now sketch the first run line. Next, we will sketch our second run line perpendicular to the first. Revit will automatically connect these run lines, and clicking the check mark completes our ramp. In 3D view, we can see our newly created ramp. As with stairs, the railings on the ramps act as separate elements from the ramps themselves. Therefore, they can be selected and deleted if they are not necessary. Once stairs have been created, we can change their sketch and properties in order to produce new shapes and steepnesses. First, we will select the stairs and then select the Edit Sketch tool. Now we will create new boundary lines for our sketch. Let us start by creating boundaries that taper off as the stairs get higher. After the new boundary lines have been created, we can use the Modify tool to select and delete the old ones. In our sketch, notice that our riser lines do not extend all the way to the boundary lines. However, when we select the green check mark to finish the sketch, Revit automatically extends the risers. After finishing the sketch, we must check to make sure that the risers are still going in the right direction. Then, switching to a 3D view, we can see our completed staircase. Boundary lines can also be edited for other stairs, such as L shapes. Once again, select the stairs and open the Edit Sketch tool. Using a curved boundary line, let us modify the sketch of our stairs. Once completed, let's delete the old boundary line and finish the sketch. We can now see the finished stair in our 3D view. Risers can also be modified using this same technique. After selecting the stairs, open the Edit Sketch tool, but instead of creating new boundary lines, we can choose to make new riser lines. Now, let's create a new riser. Again, we will use the Modify tool to delete the old riser. We can do this multiple times for different risers. Once all the new risers have been created and the old ones have been deleted, we can complete our sketch. Let's return to our 3D view to see the completed stairs. Once a stair has been placed, we can change the stair and railing type. After selecting the stair, we can assign it a new type. Multiple types are available for us to use. We will start by selecting Residential Open Two Sides. Notice the different stair, but how the railing stays the same. This process can be repeated until we are satisfied with the type we have chosen. Railings can be treated in much the same way as the stairs themselves. Let's select the railing and change its type until we are satisfied. Both railings and the stairs themselves are separate elements, and so their types must all be changed independently of one another. By editing type properties, we can create steeper or shallower stairs. Open the Stairs tool and select Edit Type. To create a new, steeper stair, let's first duplicate an existing type. Choose Residential Open Riser, duplicate it, and rename the new type Residential Open Riser Steep. By default, Revit sets the minimum tread depth to 11 inches and the maximum riser height to 7 inches. Let us change the minimum tread depth to 8 inches. Let's now change the maximum riser height to 11 inches. Selecting Apply will create our steeper stair type. Notice that Revit will now calculate the desired number of stairs based on an actual tread depth and a target riser height. Let us sketch a run, finish the sketch, and then move the stairs into position. Switching to the 3D view, we can now compare the steepness of our new stair to the much shallower steepness of Revit's default settings. Using what we have learned, we can now make spiral stairs. Select the Stair tool and sketch a spiral run line. First, let's select the desired radius of our spiral. Once selected, we can place riser lines in the same way we did with the straight stairs by dragging our cursor along the run line. The number of risers created and remaining will change as risers are placed or removed. Once all the risers have been created, we can now finish our sketch. After reversing the direction of the stairs, we can return to the 3D view to see what we have created. For longer run lengths, this technique can present us with some problems. To demonstrate this, let us create a shallower stair type. Open the Stair tool, edit the type properties, duplicate the Residential Open Riser type, and rename it Residential Open Riser Shallow. Next, let us decrease the maximum riser height, which will increase the number of steps needed to reach the second floor. This will in turn make it necessary to place a longer run line. Using this new type, we will begin placing the spiral staircase after selecting the radius of the spiral. However, Revit will not allow us to place a run line on top of another run line. Therefore, once 360 degrees is reached, the direction of the stair changes, or the riser count starts over. Essentially, the steepness of our stair type is too shallow to make a complete spiral. To fix this, we can edit the stair properties. To increase the steepness of the stairs, we can decrease the actual tread depth. By changing this value, Revit will warn us that we are overriding a type property. Let's select OK to accept this override. To place the new stair, select a radius and draw the run line. By making the stairs steeper, we are now able to place all of the risers. We can now finish the sketch, change the direction of the stairs, and then return to the 3D view to see our final spiral stair. Sometimes, stairs are placed in the middle of floors, and therefore, openings must be provided for access. Before cutting an opening, we must determine how much of the floor we need to remove. To do this, let us select the stair and take a look at its properties. The riser height tells us that for every riser line, there is a change in height of about 7.5 inches. Doing a quick calculation, we can determine that we need about 13 stairs to have a clearance of about 7.5 feet. Let's now select the floor and open the Edit Boundary tool. We will now sketch a new set of boundary lines within the current sketch to represent our opening. Open the Pick Line tool and select the edges of the stairs. For the final boundary line, count out 13 risers in order to get the desired clearance. Finally, connect all of the boundary lines using the Trim tool. With the opening fully complete, finish the sketch and our opening will appear. Now, let us switch to our 3D view to see the opening that we have just created. Openings can be modified in much the same way as they were created. Open the second floor plan and select the floor. Once again, open the Edit Boundary tool. We can now add or delete boundary lines to achieve the shape of our desired opening. For this example, let's create a round opening using our sketch tools. Once the desired opening has been created, we can finish the sketch and the new hole will appear. Returning to our 3D view, we can see the opening that we have just created. In the presence of openings and ledges, it is often necessary to place railings. In the second floor plan, open the Railing tool. Using the Pick Line tool, we can choose existing lines that we would like railings to be placed on. After finishing the sketch, our railing will appear. Notice that the railings are directional, as the handrails can be placed on either side of the railing. To change the location of the handrail, select the railing and click on the small blue arrows. This will place the handrails on the opposite side of the railing. Returning to the 3D view, we can see that our handrails are now on the proper side. Railings can be added anywhere within the model. Returning to the second floor plan, we can add railings to the edge of our balcony. This can be done by picking existing lines, or we can draw new lines. After the railings are placed in the desired locations, finish the sketch and the railings will be created. Once placed, railings can also be modified. To change a railing, let's select it and then choose an alternate type. We are also able to edit the type properties of railings. Select a railing and edit its type properties. This will allow us to duplicate rail types to create new ones. We are also given the option to change the rail structure. In this menu, we can edit each rail separately, from its materials to its type. Selecting OK will apply these changes. To improve circulation, it is often necessary to place elevators within a model. The first step is to place the elevator component. In the second floor plan view, let's open the Component tool and find the elevator component. If the elevator cannot be found, it is possible that it needs to be loaded into the project using the Load Family tool. When the elevator component is located, we can select it and place the component in our model. Next, let's navigate to the first floor plan view, where we will place another elevator component directly under the first. In our 3D view, we can see our newly created elevators. In order to enclose the elevator, we must now create walls along the borders of the elevator component. Return to the first floor plan view and open the Wall tool. Next, let us edit the top constraint property in order to extend the walls all the way to the roof. Now we can change the reference location line of the walls to the interior finished face to aid in wall placement. To place the walls, let's select the outer lines of the elevator and connect them using the Trim tool. With the walls placed, we can return to our 3D view to see the enclosed elevator. To add an opening for the elevator, we can edit the floor boundary, as we did before, or we can create a shaft. To create a shaft, we will open the Shaft tool. Once again, we can pick lines in order to create the sketch of the shaft. In the shaft properties, notice that the shaft will extend from the first floor to the roof. This tool creates an opening for the elevators by editing the boundaries of all the floors and ceilings located in this range simultaneously. Once the outline of the shaft has been drawn, we can finish our sketch and the new shaft will be created. To create access to the elevator, we will once again create an opening, but this time we will use the Wall Opening tool. Starting on the second floor, we will select the wall that we wish to make an opening in. Next, Let's select the start and end locations of the opening. We can now select the void in order to view its properties. The top offset is measured from the roof, while the base offset is measured from the first floor. Switching to a 3D view, we can now clearly see the doorway that we just created. We can now repeat this process in order to create access to the shaft on the first floor. When finished, we can switch to a 3D view to see our completed elevator.